Okay, welcome back. And today is going to go over measurements of dispersion, or what we call variation. So that's what we're going to go over today. So last time we talked about measurements of central tendency, which is talk about the middle of the data, the center. Okay, so we're talking about the mean, median, and mode. Okay, today we're going to say, okay, well, when we talk about the data, how is it spread out around the center? So is it really tightly compact around the center, or is it really spread out? And so that's the measurement of dispersion. Okay, so the bigger the amount of dispersion, the more spread out. The less dispersion, the more compact it is around the center. Okay, so that's what we're going to talk about today. And there's different measurements for dispersion. We're going to talk about a few of them, but we're going to mainly talk about two and stick with that for the rest of the semester. Okay, the others we're going to talk about, but we don't use them very often. Okay, so again, you're going to want to know this stuff. Okay, so measurements of dispersion. So let me write that down so we can get started here. I'll use this. Okay, so measurements of dispersion. Okay, what we call variation. Okay, and typically what we're talking about is how spread the data is, how spread out the data is. Okay, so now I'm going to cover a couple of these. And the first one we're going to cover, which is the most common one we're going to deal with in this class, and that's standard deviation. Okay? Standard deviation is a measurement of overall variation in the data. How spread out is the data compared to the mean, in this case, specifically to the mean. Okay? And so we're going to talk about what it is, how you calculate it. We're also going to talk about variance, because variance is directly related to standard deviation. And then we're also going to talk about other measurements that we calculate that measure dispersion. And then after that, after this section, the next section is going to be relative position. Okay, so that's how we're going to handle things. Okay, so the first thing I want to do is talk about standard deviation. And again, standard deviation is the most common characteristic or common statistic or parameter, if you will, that we use to describe the overall distribution, or excuse me, not distribution, but dispersion or variation in the data. Okay? The larger the standard deviation, the more spread out the data is. The smaller it is, again, the more compact the data is around the mean. Okay, so I'm going to talk about population in the sample. But for this class and for most purposes, we use the sample. Okay, especially in statistics. Okay, so here's the characteristic. So it's non-negative. It measures overall variation in a sample, okay, or in a data set. So it measures overall variation in a data set. And it tells you how far a value is relative to the center. The middle, the mean, specifically. Okay, so it can tell us how far a specific value is from the mean. Okay, that's what it can tell us. Okay, and that's why it makes it useful, and that's why we use it, is because it's easy to interpret. Okay, And we'll talk about variance later, but again, variance again is directly related to standard deviation, but we use standard deviation the vast majority of the time because it's easy to understand and you have to calculate one to get the other anyway. And with modern technology, like with the graphing calculator that I'll show you in another video, you can calculate this stuff immediately without using the formula. But we're going to start with the formula because you have to know the formula, what goes into it, what goes behind it, how you derive it, and then from there, once you know the concept and what it's used for and how to interpret it, then you can just get it from your calculator or from a software program. Okay, so now here are the formulas. Okay, so let's stop. I just want to make sure I don't. Okay, so let's do this. Let's start with population. Population, standard deviation. Okay, just want to make sure I don't go off the board. Okay, so now, population standard deviation. The formula is going to be this I'm going to write on the board. We use Greek letters for the population. So remember, we're going to use, so this is the parameter. So what we're going to use is sigma, the Greek letter sigma, lowercase sigma. That's going to be what we're going to use for the population standard deviation. And that formula is this. Okay, so it's going to be the square root of this formula in here, which is the summation. So again, we're talking about capital sigma, so it's the summation of all of these values. Well, what are these values? These values, so inside the parentheses represents the distance from the mean that a value of X, or the sample, one of the samples, or a value in the population is. Okay, so we take a value of X, some value in the population, and we see how far it is from the mean. That's what we call a deviation. Okay, so what we're going to do is we're going to take all of the measurements, all of the deviations for every observation in the population. And we're going to take all of those deviations, and since some values are going to fall above the mean and some values are going to fall below the mean, that means some deviations are going to be positive and some deviations are going to be negative. And what happens is if we have a bunch of negative and positive, well, think about the mean. We're talking about the mean, right? So the mean is in the middle, right, roughly. So we would expect about half of the values or the observations in the population to fall below, and we would expect about half to fall above the mean, the population mean. So if we took all of those deviations and summed them up, we'd get something that was very close to zero, which would not help us, okay, as far as telling us how spread out the data is, okay? So what do? Well, to get rid of the negatives and make everything positive, we're going to square all of the deviations. So that's where this square comes in. And then what we're going to do is we're going to sum all of those deviations, and that's what we're going to get here. So we sum all of the squared deviations, and then finally we divide by the sample size, not the sample size, I'm sorry, the population size. Capital N is for the population. And then after we do that, we take the square root. And that answer, or that calculation, is the standard deviation of the population. Okay, make sense? Good. Okay, so now that's population standard deviation. Here is how you calculate the sample standard deviation. And if you recall, when we dealt with mean, the sample mean, right, we had this. Right? That was the sample mean. And the only difference between the sample mean and the population mean was we were using capital N for the population size instead of N. Okay, so there was not a lot of difference between the two formulas. Okay, so in this case here, mu, which was the population mean, was just the summation of x over capital N. Well, we're going to see a similar difference, but it's going to be a few other things that are going to change, okay, when we talk about the sample standard deviation. So let me show you what that looks like, and then I'll explain it. Okay, so let's write down sample standard deviation. And so we represent sample standard deviation using letters, and that letter would be S. And the formula is going to be very similar, but with some key differences, okay? Okay, so let me explain this. So here's the formula for sample standard deviation, okay, S. So we take the square root, but notice in the middle here, instead of mu, we're using x bar, the sample mean, okay? So that's one difference. We're going to use the sample mean instead of the population mean, okay? The other thing too is in the denominator here, we're using the lowercase n for sample size, okay, instead of capital N for our population size, but we're also subtracting off 1. Okay? Now I'm not going to explain that to you in this video, that's going to be for a later video, but there's an important reason why we're dividing by n minus 1 that'll become clear later instead of just n, like we did with sample mean. Okay? So that and that are the two big differences. Other than that, they look very much similar. Okay? So again, this is the one we're going to deal with mostly because most of the time we deal with samples and not populations. Okay? So anytime we deal with this, or excuse me, a sample, we're going to be using this. Okay? I'm also going to show you again how to get this from your calculator in another video. Okay? So for the time being, these are the formulas. You're going to want to know these formulas for calculation purposes with small data sets. Okay? So just be aware of that. Okay? But you are going to be able to get this using your calculator. Okay, so let's use an example. So again, let's go with an example here. So let's start, and here's my example. Okay, so let's say you're in a 5th grade class, and the teacher was interested in the average age and the sample standard deviation for the ages of the kids in her class, the students in her class. Okay, so here's the sample of the students. Okay, or actually, this would actually be the population because it's all of the students' ages. So this would be an example where you're actually calculating the population standard deviation, okay, for the students in her class. Okay. No, but let's assume this is a sample. Let's just assume this is a sample. Because let's say this is all students that she teaches in this class. Okay, and let's say this is a sample. So here's the sample. Change this. Okay, so there's my data set, okay? So how many observations do I have? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so my sample size is 20. So immediately I know that n is 20, right? So now here's how I would calculate it. Now you can use the formula, which is fine. You can use this formula and just calculate it directly using the formula, and that's fine. I'm going to show you another way that uses a table and to build the formula. And then at the end, you'll get the same answer, okay? So again, either way is fine, but I'm just show you an easier way as far as just to keep things organized for people who aren't comfortable just plugging and chugging into a formula, okay? So let's do that. So the first thing I'm going to do is I'm going to set up the table of values, okay? So I'm going to take all of the values here, and I'm going to go 9, 9.5, so this is x, okay? So I'm going to do that. So 9, 9.5, 9.5, 10, 10, 10, and then 10.5, 10.5, 10.5, 10.5, and then 11, 11, 11. How many, do I have enough room here? Let me just see, okay. I think, let me do this. I have, yeah, let me do this. It'll be kind of tedious. Let me do it another way. So here's the data. Let me do it over here. So I'm going to erase these for a moment. So hopefully you wrote those down. Okay, so let me put the formulas over here. We'll do it in 2 steps. That'll be better. So n is 20, and s is the square root of the summation of x minus x bar squared over n minus 1. Okay, so we'll use that. So now what I'm going to do is I'm going to draw a table. Normally, just so you know, I wouldn't do this with a large data set like this. I'd use the calculator, but again, I'm going to show you that it does work. Okay, so let's use x. So x is going to be right here. So here are x values. So I'm just going to write down the x values. So it's 9, 9.5, 9.5, and then 10, 10, 10, 10, 10.5, 10.5, 10.5, and 10.5. And then I've got 6 11s. And then I've got 11.5, 3 of those. So 11.5, 11.5, and 11.5. Okay? So again, just bear with me. Pause if you have to, but I'm going to go through this slowly because there's a lot of numbers here. Okay? Now, the first step after this is I need the mean. I need to calculate the mean. Okay? So how do I calculate the mean? I'm going to get x bar, and I'm going to use the formula, summation of x divided by n, where n is 20. So I'm going to sum all of these values up. Okay? So this is 999, so that's going to be 27. So plus 40, 50, 60, 70, 80. 80 plus 27 is 107. And then how many 11s do I have? I've got 6 11s, so that's 66. So I've got what? 107 plus what? 66? So that's going to be 107 plus 66. That's going to be 113. So that's going to be 173. And then I've got 2 more or 3 more 11s. So that's 73 plus 11 is 80. 80, so that's 210. Okay, so now at 210, I've got 1, 2, 3, 4. So that's 114. So I believe it's 114.5. Okay, double check that. I'm going to double check that right now. So let's see. 9, 7. Okay, that time I got 190.5. Okay, so I'm just going to double check again. Okay, so, okay, the way I'm going to do this, so 9, 9, 9, 27, 37, 47, 57, 67, 77, 87, 97, 107, 17, 27, 37, 47, 57, 67, 77, 87, 97. Okay, so I missed a 10, so 97. So 197, and then 197 plus 1, 2, 3, 4, 5, 6, 7, 8, 9. So 97 plus 9 is, just want to make sure I'm not missing anything. Yeah, 197 plus 9 is 106, and then plus 1, 2, 3, 4, so 210.5. Okay, so 210.5 divided by 20 equals what? Oh, well, it should be so about 150, about 53. So let's do that. So let's see. $10.52. Yep. So it's 10.525. 10.525. But again, because we're dealing with numbers, the original data goes out one decimal place. We're going to go out to 2 decimal places. So this will be 10.53. So what we're going to do is we're going to subtract off the mean from every one of these. Okay, so I'm going to use the calculator to write these out. And in this case, I wouldn't bother doing it this way. I'd use the calculator. But again, I just want to make sure I show you how to do this. So the second value, so again, this is 10.35. So now what I'm going to do is I'm going to subtract off 10.53 from each one of these values. So this column, next column, is just going to be x minus x bar. That's what my column is. And so what I'm going to do is I'm going to subtract off this from each one of these and put it in here. So I'm going to do that. So we got 9 So 9 minus 10.53 equals, so negative 1.53. So negative 1.53, and then 9.5. So 9.5 minus 10.53 1.53 is negative 1.03, and then the next one's going to be 1.03, and now I got 10. So now 10 minus 10.53 is 0.53, negative 0.53. I should have known that. Negative 0.53, negative 0.53, negative 0.53, negative 0.53. Now, here's negative 10.5 minus 10.53. Okay, so that means this is going to be negative 0.03, right? So again, you can just double check that. So 10.5 minus 10.53. Again, yes, negative 0.03. And that's going to be all the way down. Negative 0.03, negative 0.03, and negative 0.03. Now the 11s. Well, 11 minus 10.53 is going to give me 0.47 now. So now I've got a positive number. So this is going to be 0.47, 0.47, six times total. So 0.47, 0.47, 0.47, and 0.47. Okay, so now then we got 11.5, the last one, so 11.5 minus 10.53 is 0.97. So 0.97, 0.97, 0.97. Okay, so now that's this piece in the middle here. So now the next part is to square it. So the next column I'm going to have is I'm going to square all these values. So I'm just going to take this column and square it. So 1.53 squared is, I'm just going to go out 2 decimal places, 2.34. 2.34. So I might get a little bit of round off here because the actual value is 2.3409, but again, I'm just going to go out 2 decimal places. So normally you don't want to do that. So normally you just want to keep all of these in here. So then we get negative 1.03 squared. And that's going to be 1.0609. So 1.0609, and again, that's going to be repeated, 1.0609. And then 0.53, so negative 0.53, that's going to be 0.2809, 0.2809, 0.2809, 0.2809, 0.2809, and then 0.03, this is just going to be 0.0009, because it's just 3 squared, so it's 0.03 squared is 0.0009. So 0009, 0.0009, 0.0009, and then 0.47 squared is 2209, so 0.2209, 0.2209, and we're going to do this a total of 6 times. And then 0.97 squared, 9409. So 0.9409. Okay, so now the last step as far as the numerator goes is now all we have to do is sum this up. Okay, so I'm just going to sum these up real quickly. So I get 9.66666. So the summation here, so the summation of this column, which is just the summation of x minus x bar squared. So this is the numerator. And this numerator turns out to be 9.6666, right? So now, all we have to do is take this and divide by n minus 1, which n minus 1 is 19, and then take the square root. So let's do that. So let's, oops, I just want to make sure, do I have enough room? I think I do. Okay, yes I do. Okay, just want to make sure. So here, so now I've got the formula. So S, right, equals the numerator, which is 9.6666, divided by n minus 1, which is 19, and then we take the square root of it. And so what do we get? Let's see, we divide by 19, and we take, and we get 0.713, and that's our standard deviation. Okay, and that's it. So what do we do? Well, so this was heights, right? So no, ages. So these are in years. So the standard deviation would also be in years. So the standard deviation is about, about 71,000 or 7100ths of a year. Okay, is what the standard deviation is. Okay, so that's how you calculate it. Okay, again, I would not do it this way using a large data set. If I give you 5, or if you have 5 or 6 numbers, very easy and quick to do, relatively speaking. But if I have a large data set like this, I would use the calculator. So see the video that I do on calculating statistics for one sample, specifically for standard deviation. And I show it in there, okay? So far, so good, right? Any questions about this? So this is how you would calculate standard deviation. Okay. If you're using a table, or you could just plug it into your calculator, but again, you could mess up that way too. Okay, so now what's next? Okay, so now, what if you wanted to calculate the standard deviation and you don't have the data? You have a frequency distribution. Okay, so let's do that. Okay, so now here you had sample data. What if you don't have sample data? What if you just have a table, a grouped frequency distribution? So you don't have the data, all you have are the classes along with the class limits, or even the class boundaries. How would you do that? Okay, well let's look at this. Let's look at an example. So okay, so one thing to keep in mind, if you have a frequency table, a grouped frequency table or distribution, you need to realize that in this case we're going to use the midpoint of each class because we don't know what the data is, so we basically just use the middle of each class. So we assume that all of the values in the first class are going to be all the same at the midpoint. Okay, it's an estimation, it's a guess, or not a guess, it's an estimation. Okay, so there's a little bit of error in here, but again, that's the best we can do if we don't have the data. Okay, so let's use this as an example. So let's say we have these classes with these frequencies. So let's say we have class, and we have frequencies. Okay, so we have, okay, so the class width is 3. So if I just add 3 down, this is what I get. And these are the different classes with the class limits. Okay, so the first thing I'm going to do is I need the midpoints. Okay, so I'm going to make that x of MP, MP for midpoint. And so what's the midpoint of the first class? Well, it's going to be the sum of these two limits divided by 2, which is just going to be 1. Okay, so the midpoint of this one is just going to be at 1, and then the class width is 3, so then I just have to add the class width over and over again to get the rest of them. So 1 plus 3 is 4, plus 3 is 7, plus 3 is 10, plus 3 is 13, and plus 3 is 16, which makes sense. Okay? So now that I've got the midpoints, the frequencies are here. 1, 6, 10, 7, 0, and 2. Okay, so let's say this is the setup now. So now what I'm going to do is I'm going to use the formula for calculating the standard deviation of a frequency distribution, a grouped frequency distribution. Okay, so the way you do it is you're going to use the midpoints in the calculation. So it would be the summation of the products of these two things. So I'm going to put in here, and I'm going to do the deviations using the midpoints. So it's going to be x of MP minus x bar. Where does x bar come from? X bar is the mean of the frequency distribution, which we talked about before in the last section. Okay, so here's the midpoint, or excuse me, not the midpoint, the mean squared times the corresponding frequency. Okay, so we have to multiply by corresponding frequency, and then we divide by n minus 1. The sum of the frequencies minus 1, right? Just like we saw when we were dealing with the mean of a frequency distribution. We summed up all the products of the midpoint times the frequency divided by the sum of the frequencies, which turned out to be n anyway. So in this case, n minus 1, same thing. Okay, so let's do that. So now here, we got to calculate the mean of the distribution. So the mean, remember the mean, so x bar equals the midpoint. So x of MP times the frequency divided by n. So if we do that, so let's do that. Again, normally just use the calculator, but again, you want to be able to do this. We're not going to do this in class, but again, I can do it in the video just so you know that you can see this is done. So let's do this. So we got 1. Okay, so if we take these two numbers here and multiply them, we get 1, 24, 70, 70, 0, and then 32. And if we add those up, we get 147, or excuse me, 197. So the sum, the numerator here is going to be 197 divided by n, which is the sum of the frequencies, right? So that's going to be 20. No. Yeah, it was, no, hold on, that's different. So this is going to be, so this is going to be 17, 24, 25, 26. So the frequencies add up to 26. So sum of the frequencies equals 26. That's our n, our sample size. So just let me do that again. 17, 24, 26. So we're going to divide by 26, and so our mean becomes 7 point, we'll just go one decimal place. So 7.6. 7.6. That's the mean. Okay. So now, with that mean, now we can go ahead and calculate this. Okay. So now we're going to subtract this piece. So we're going to do that. So let's extend our table. Yeah, sorry. Move this up here. So this is going to be okay. So now we're going to do our subtraction minus x bar. So x bar is 7.6. Just want to make sure that's right. Yep, that makes sense. So 7.6. So 7.6 we're going to subtract from each one of these. So this is going to be 1 minus 7.6. This is going to be 4 minus 7.6, 7 minus 7.6, 10 minus 7.6, 13 minus 7.6, and then 16 minus 7.6. So now this is where I would do my first check to make sure things make sense. Okay? So if I subtract these, let me get my calculator. So 1 minus 7.6, oops. So 1 minus 7.6 is negative 6.6, makes sense. Negative 6.6. And then 4 minus 7.6 is going to be negative 3.6. This is going to be negative 0.6. Okay. And then 10 minus 7.6 is going to be 2.4. And then 13 minus 7.6 is going to be 5.4, right? And then 16 minus 7.6 is going to be equal to 8.4. So that should all make sense. Okay, so now let's add these up and see if they add up close to 0. They should. Okay, so let's do that. So 6.6 plus 8.4. Oh, I missed something here. Hold on. Did I miss something? 1 minus 7.6. Hold on a second, because that didn't add up right. Let me just make sure. It's 1 minus 4 minus 7 minus 10 minus 13 minus 16 7.6. So that's right. oh, you know what, I think it doesn't, okay, disregard that. It doesn't, this is not gonna work because we're dealing with a distribution, and we're dealing with a midpoint. So this will not necessarily work because we're dealing with a mean and we're dealing with a frequency distribution. So I don't think it's gonna work every time because it's not working very here at all. So here's what I'm gonna do. I'm just gonna continue on. And so just make sure, okay, I got enough room. So then the next thing I'm gonna do is I'm just gonna square these. Okay, so now I'm just gonna square these numbers. And so I get 43.56 and 12.96. Okay, so here's the numbers. So now all I'm going to do is sum these up and I'll have my numerator. So sum, oh no, hold on a second. Nope, not yet. Remember I got to multiply by the frequency. Okay, so now what I'm going to do is I'm going to take these values multiplied by the frequencies and then I'll sum. Okay, so now I'm just going to take this column and multiply by this column, by the frequencies. And so, if I do that, I get so that's just multiplied by 1. So I'm just going to 43.56, 12.96 times 6. 77.76, and then 0.36 times 10 is just 3.6, and then 5.76 times 7 is 40.32. This is just 0 because this times 0 is 0. And then this times 2 is just going to be double that, so that's going to be 141.12. Okay, so now I'm going to sum this up. So if I sum all of these up, this is what I'm going to get. Oops. And so if I do that, I get $306.36, and that's the numerator. So that's that piece here. So far I've got 306.36. Now what's n? Well, n is 26. So it's n minus 1, which is 25. So this becomes the square root of 12.2544. And so what do I get? I get 3.5. So the standard deviation, the standard deviation for this distribution is 3.5. 3.5 what? Well, we don't know. It's just they don't tell us what the what the value, oh, no they don't. They don't tell us the values of what this is. Okay, but anyway, it's just 3.5. Okay, so hopefully you don't have any questions. Again, email me if you have any questions. But go over back through this and just slowly go through this. Again, this is we're not going to use this in class, but again, this is how you could calculate it using the formula, using this formula for standard deviation when you have a grouped frequency distribution. But really, the calculator. Okay, so again, watch the video on how to do this in the calculator. Much easier to do. Okay. Okay, so let's see what we got next. Okay, so here's a note before we move on to the next topic. The note I want to say is extreme values. So when we talk about extreme values, remember in the previous videos that I've done, we talked about skewness. We talked about distributions that were symmetric and distributions that were skewed. So when we have large data sets or large populations that are symmetric, then standard deviation is very useful. Okay, as I said, it's the most used statistic or that we use as far as measurement of variation. Okay, that's if it's symmetric. But what if we have skewed data? Okay, or if we have